Hey everyone, so many of you watched my annihilation of flat earther David Weiss, a con man who makes money peddling the dumbest hoax on the entire internet. Following that exchange, I visited with friend to the channel Fight the Flat Earth to do an analysis of the debate, and we decided to condense that down to a critique of the 5 dumbest things he said. If you fancy the longer version, that is linked below. Otherwise, enjoy this short trip down memory lane.
He knows a lot about the science stuff. Professor Dave explains.
I know your talking points. So this works because that's not moving. The things in the sky move. So if you take the third one from the left, which I know is flat, and you move it around, it's going to start to change shape, right? If the moon was a flat disk, I don't even know if that's one of your talking points or not. As it passed over you, it would change shape. It would
I don't think the
distort.
moon is a flat disk at all.
Okay, so it doesn't matter though. That's why what you're saying is stupid, because these objects do not move. Now, the other problem is it's not just about shape, it's about other things like composition. Do you know what spectroscopy is?
Yeah, spectroscopy is you can measure gases, but it has to be in a container. Where's the container?
No. Stop. We are looking at light. We're looking at light, and we are understanding about the materials, right? We're understanding the composition of things based on light. So when you start talking about gases, you show me immediately that you don't even know what spectroscopy is. So you do not know the ways in which we figure out things about celestial objects. You literally don't even know the definitions of the words that represent the techniques that we use. So why are you even talking about it?
So my question is, spectroscopy needs to be in a container. Otherwise, you don't know what you're looking at.
Spectroscopy needs to be in a container. The study of how light interacts with matter needs to be in a container. What does that mean?
Otherwise, when you're looking at the moon, you don't know what gases you're seeing in between us and the moon.
Gases? The moon is solid. The moon is a solid object.
How do you know that the moon is solid? Spectroscopy needs to be in a container. Otherwise, you don't know what you're looking at.
That phrase is one of the
dumbest
dumbest
sentence
ever
uttered by a human person.
Spectroscopy needs to be in a container. Like,
yeah, I mean, what this does is just shows you the desperation with which he needs to stick to a script, because he hears words he doesn't understand, and then he goes, where can I filter this into one of my dumb talking points? Oh, maybe I think that sounds a little bit like atmosphere needs a container. So let me take this unrelated thing he's trying to say and jump to this like in a completely nonsensical manner. Like,
so he's trying to connect the argument of gas needs a container with spectroscopy, because he's saying that spectroscopy measures gases. So therefore you can't do spectroscopy without a container because gas is involved.
Yeah, but is it? I mean, spectroscopy is measuring light. You can do spectroscopy on we're just measuring light that's emitted. You can do it with a solution. You can do it with. It's not specific to gases. So it's just gases need to be in a container. So spectroscopy needs to be in a container. It's like, what the hell?
I mean, that sounds like T-shirt material to me. Spectroscopy needs to be I'd buy that with a Professor Dave face on.
That'd be pretty good. That's a good shirt. Yeah, I like that.
So there is a few phrases that flat earthers love to parrot to try and seem like they know what they're talking about. One of these mantras is that gas needs a container. This particular dumb thing comes from someone cherry picking a few words on a website about gas laws, which led to a massive lie and misunderstanding about the second law of thermodynamics. But they hold on to their religious chanting of gas needs a container to try and debunk things like the Earth having an atmosphere when space is supposed to be a vacuum. Of course, we all know that gravity deals with that just fine, no problem, but you say gravity to a flat earther and their eyes kind of glaze over and they start drooling a little. But here, Flat Earth Dave is using the same argument to try and somehow discredit spectroscopy. His logic is that spectroscopy measures gases, and as gases need to be in a container, you can't use spectroscopy in so-called space. Yeah, that's dumb on quite a few levels. He is simultaneously showing a lack of understanding of space, gravity, light, vision, and what spectroscopy actually is. That's quite impressive. Electromagnetic radiation, like the visible light spectrum, carries energy in waves, and when these waves hit something, they cause an interaction, some change in the matter that they hit. The study of these effects of these interactions is called spectroscopy. When the waves and matter interact, two different things can happen, either absorption or emission. Absorption is when electrons in matter absorb energy from electromagnetic radiation and move from a ground state to an excited state. Or vice versa, if matter moves from an excited state to a ground state, it then emits electromagnetic radiation in energetic waves, and we call this emission. Spectroscopy isn't just for measuring the interactions between radiation and gases in deep space, though. It's used in everyday life. Measuring the light from these interactions allow us to do things in the medical field like look inside you with MRIs, do cancer research, drug identification, all the way to quality control in the beverage industry and chemical research. Even in home improvement stores to match the color of your couch to your wallpaper. Spectroscopy does not need to be in a container. This is what flat earth conmen like David Weiss do, try to sound smart and hope that you are too dumb to not notice, but unfortunately for him, he was debating Professor Dave.
So getting back to your point where you have somebody in Santiago, somebody in Johannesburg, and somebody in Australia, when they see the Southern Cross, well, they don't see it at the same time. They see it 12 hours apart from Santiago.
They don't see it at the same time? So people looking south can't see the night sky at the same time?
David, if you understand what the flat earth model is, if somebody's in Santiago...
You don't have a model.
Listen.
Yeah.
Stop being a dick. Okay.
You stop being a dick. Your entire existence is being a dick to all of science. So stop telling me to stop being a dick.
Keep going. So somebody's in Santiago and it's midnight. Yeah. They're looking at the Southern Cross. Well, somebody in Australia that's looking south, they're looking at the noon sun. You tell me how they
noon
can see
sun? How many time zones apart are they? Are they 12 time zones apart?
Well, at noon, close to noon, right?
Okay, no, first of all, not close to noon, but it doesn't matter. How about you go 4 hours apart? Why don't you go 4 time zones apart? They should still be looking in completely different directions. 12 midnight, 4 a.m., night sky, both looking south, both can see the Southern Cross. On your pizza world should be looking in completely different directions. Explain that.
Dave, when the only time that can happen is in Johannesburg and Santiago, and if you add magnetic declination in there, they're both looking in the same direction.
Magnetic declination?
Yeah.
So you think just saying the word magnet is going to be an argument here that's going to work for you?
Look up the magnetic declinations of those areas. You don't know what direction you're facing, right? There's certain areas of Antarctica that the magnetic declination is 170 degrees. So when your compass says north is that way, it's 170 degrees the other way, according to NOAA or whoever's in charge of that, right?
Look, you can dress it up however you want. We're talking about looking this way and looking that way, and they see the same thing. And you're fixating on Santiago and Johannesburg because you think that they're far enough apart that they're not going to both be nighttime. I'm telling you, you can go any distance apart. Just go from Perth to Sydney, right? That's far enough apart that if you're both looking directly south, you're looking in different directions, and you can see the same thing. You cannot explain that. That's why you're trying to throw out jargon to confuse people. When in doubt, say the word magnet.
Yeah. So he thinks magnetic declination can physically change the position of stars based on where you're looking. Because even though those stars are in different places on a flat Earth, magnetic declination makes it for some reason look like the stars would look like if you were on a sphere.
This was probably his most desperate moment in the entire exchange.
Yeah.
He just had absolutely nothing to say.
So I genuinely think he doesn't understand in the slightest what magnetic declination is. Magnetic declination is simply the difference between where your compass will point and what we class as true north, right? That's right. It. It's the and
because the poles, the magnetic poles are not aligned with the geographic poles.
Yeah, exactly.
And in fact, the magnetic poles move. Like this is another funny thing about like they want the North Pole, like they want magnets to point towards the center of the pizza land. That's geographic North Pole. That's not the magnetic North Pole. And the magnetic North Pole moves. So I'm sorry, like a little magic. They think they at Santa's workshop they have like a big pole or something, and all the magnets are pointing towards that. Well, no, it's moving around.
Yeah.
So.
It is desperation. Oh, magnetic declination makes the stars appear in the way they should, but it's still flat for some reason.
It's the dumbest thing I've ever
I
heard.
wish that you'd asked him to explain magnetic declination, because I think that would have been
I
pure
should have
comedy.
said,
Yeah.
yeah, I should have said define magnetic declination.
So we all know that flat earthers like to throw out scientific jargon without having a clue what it means, but Weiss took that to the next level when he tried to bring up magnetic declination. Of course, anyone can see that on a flat earth, south is a completely different direction for every single longitude line, such that it's impossible for people in different places to look south and see the same stars, even though in the real world that is what happens, because south means toward the South Pole. This singular fact proves the Earth isn't flat, but con man Weiss desperately needed a way out of this obvious conclusion, so he just decided to say NASA and spew the words magnetic declination as though that was going to save him. Since we didn't get to properly discuss how unbelievably stupid that was for him to say, let's talk about it now. Once again, on the pizza land, two people on any two longitude lines would look south and see completely different stars, as they would be looking in totally different directions, as opposed to what they actually see, which is the same stars, since they are actually looking in the same direction. Weiss's reply was magnetic declination. So what's that? Magnetic declination is simply the angle of the difference between true north, which is at the geographical North Pole, and magnetic north, which points toward the magnetic North Pole, the point where Earth's magnetic field points directly downwards. The angle of magnetic declination changes based on your position on Earth, and it also changes over time, because the magnetic North Pole moves. The Geological Survey of Canada determined in 2005 that the magnetic North Pole was west of Ellesmere Island in northern Canada, and then in 2009 it entered the Canadian Arctic and is now moving toward Russia at 55 to 60 kilometers per year. That's what magnetic declination means. So, for Weiss to try and use this concept as the reason that two observers looking in completely different directions somehow end up seeing the same stars is absolute nonsense. Earth's magnetic field doesn't magically change what people are seeing in the sky. It's just a con man using big words to try and confuse the person he is talking to, which failed miserably. This was one of my favorite sections in the entire exchange because of how transparently defeated he looked. There were a handful of moments like this where it was absolutely obvious that he knows he's lying for cash and is not interested in discussing reality whatsoever.
What about eclipses, guys? What about
Hold on.
eclipses?
Hold on.
That's
let's-
my
let's-
third
gotta-
talking point. I hope we get to it.
Let's finish this point. Your mainstream science says that because of the spin of the Earth, because of the centrifugal force, that the water bulges at the equator 14 miles high.
What?
This is what Neil deGrasse Tyson and science tells us about the spin of the Earth. The water
it
at the
doesn't.
equator, yes, it does. It
No,
bulges
it
14
doesn't.
miles high. It makes the Earth 29 miles wider at the equator.
No, that's the Earth, not the water. What are you talking about? Are you a moron, dude? The radius. This is what happened. You're very confused.
So let me ask you a question.
No, stop, because you just said a very specific number, and I know why you said that number. The diameter of the Earth is about 27 miles greater at the equator. That's the whole Earth. You're trying to pretend that it's all water, that there's just this big thing of water that's 14 miles. Is that what you're genuinely trying to say? Are you that stupid?
Well, that's what Neil deGrasse Tyson said. Your mainstream science says that because of the spin of the Earth, because of the centrifugal force, that the water bulges at the equator 14 miles high.
I couldn't stop laughing when he said that. He thinks there's like you would sail along the ocean and there'd be a physical bulge of water going up.
Yeah, a 14-mile high tidal wave is what he was saying that science claims.
Yeah, but of
why
course
would
it
science
doesn't.
claim that? It's not there. Like, what is he talking about? Like, but in the end, I understood what he was talking about. He was talking about the equatorial bulge at the equator of the Earth.
Isn't it? So it's a 43-mile difference between the equatorial and the polar diameters. It's very, very small,
Something,
right?
Yeah,
Like-
but it matched that number. It matched that number such that I knew that that's what he was talking about. That's the like the difference in the radius from the center of the Earth to the North Pole versus any point on the equator. But that's the whole Earth.
Yeah, not just the
like,
water.
does he not understand? Like like the oceans, as deep as they are to us, our tiny little bodies, are a tiny fraction of 1% of the radius of the Earth.
They're insignificant compared to
Yeah.
the radius of the Earth. So the equatorial bulges of the whole Earth, it's not the Earth is a perfect sphere and then the bulge is the ocean. Like it's just his inability to grasp the most basic concepts is astounding.
An impressive ability of flat earthers is to misunderstand literally everything. Flat Earth Dave once heard somebody talk about the equatorial bulge and jumped to the insane conclusion that you should encounter a massive hump of water 14 miles high as you approach the equator. This is what Flat Earth Dave does to try and brainwash people, throw out nonsense that might contain a correct number or two and try to make it sound ridiculous by strawmanning the actual facts. It's a kind of gaslighting. There is an equatorial bulge. Kind of. Their circumference around the equator is 42 miles greater than the circumference around the poles. This is indeed due to the centrifugal force of the rotating Earth. But that doesn't mean that there's a 14-mile hump of water, because this is the entire Earth we are talking about, including the land, and the 42 miles difference is spread out over a quarter of the Earth's surface. We can prove this is the case as well. Things weigh more at the poles than they do at the equator. At the equator, not only are you further away from the centre of Earth's mass than you are at the poles, but the centrifugal force also acts in the opposite direction to gravity, reducing the perceived gravitational force acting on you. This is why gold is measured on counterbalance scales rather than coiled spring or digital scales. You could just buy gold at the equator, head north and sell it for an easy profit. Professor Dave did an excellent job of shutting down the nonsense that David Weiss threw out. But Professor Dave is smart. He knows a lot about the science stuff. Not everyone is, and that is why it is dangerous to let flat earth conmen like David Weiss go unchallenged.
There's no place that you have 17 hours of sun. You have daylight. Daylight is the illumination of the sky. It's not the sun.
From the sun.
No, the sun is
You're saying that daylight
illuminated.
is not from the sun?
Absolutely. So if the sun
Where is it
rises-
from?
If the sun
What's
rises
making
on-
the sunlight then?
No. The sun is lighting up the sky. It's like a photographer. You have your main light and then you have your backlight. The sky is the daylight. When the sun is on the east side of your house, right on the horizon, go to the back side of your house. You can read the newspaper. Well, where's that? That sunlight's not. What's it going through your house?
That was the only time that really made me laugh out loud in disbelief. Everything else that he says, I know is so stupid, but I know that they say these stupid things. That was just like, you're saying that daylight is not from the sun? I couldn't believe that he said that. Like, what are you
Daylight is
talking
not
about?
from the sun. Absolutely. Like, he doubled down on it. You asked him directly.
For sure.
Are you saying daylight is not from the sun? Absolutely. What the actual... Jesus, man.
That was the one surprise for me in the entire exchange. That
Yeah,
was the only
I'd
thing
never
that
heard him say that
surprised me.
before, to be honest. That's not a line I'd heard him use, and I will be covering that.
At this point, Flat Earth Dave is grasping for straws anywhere he can get them. Remember, this particular video you're watching is just the top 5 dumbest things he said during the debate. In the full stream on my channel, Professor Dave and I went over all of the dumb things said in the debate. Here is the list. That was 1 hour. All of those dumb things that you just saw were said in 1 hour. Anyway, Conman Weiss is now claiming that daylight is not from the sun. His logic here is that you can go to the side of a house that the sun isn't on and still read a book. It's incredible he didn't notice that he debunked himself because he forgot one big thing. The side of the house that the sun isn't on is going to have shade. Shade because the house is blocking the light from the sun. So if the sun doesn't cause the daylight, then why is there shade? This is all leading to an attempt to debunk the fact that you can get 24 hours of sunlight in Antarctica at certain points in the year, which of course absolutely destroys the flat earth, and the best way the flat earthers have to debunk it is to claim that all videos like this one are fake.
let's say this is the northern hemisphere, this is the southern hemisphere. More of the northern hemisphere is exposed to direct sunlight, so you have longer daylight, right? So it's so hard to just do in my hand like this.
No, I get it.
But
I
yeah,
understand. You got it when we're tilted towards it, the sunlight's hitting direct, and it's more intensified here, and down here it's spread out more. Makes sense. I
yeah,
got it.
because of the curvature, so it has
I
to
got
spread
it.
out
So
around a
it
greater
spreads out
area.
more. But isn't the sun so large that all of the rays leaving the sun are parallel? And why wouldn't the parallel rays that are a little off to the left, hit us direct? Are the rays leaving the sun parallel, or are they leaving not parallel?
Okay, when you have a certain okay, here's a lateral distance. If the sun is directly hitting the part of the earth that's directly facing it, that's a certain area. Then if you move this way, we have the same lateral distance, but there's a lot of curvature here. It's covering a greater surface area.
So I have to ask a
Right?
question. So can the Earth can
Okay,
be
do you
tilted-
want to admit that I just explained that perfectly and that your talking point was invalid?
I know. I admit that you explained that perfectly, but I have to
Okay,
ask
great.
a question. So we have the pole here, and we tilt the Earth.
Mm-hmm.
Okay. And can you tilt the Earth this way? That's a tilt, also, right? Absolutely.
What? You're just turning it. What are you doing?
No. What I'm showing you is here. Here, let's say the sun is over there, and we tilt, and we're now directly towards we have a more direct angle. We're in agreement on this. But if I'm here, and I tilt it this way, well, now the sun is lower. It's now skimming. It's now skimming, and it's not hitting as direct. So here's the problem with your seasons. In the north here, in December, when we're 3 million miles closer to the sun, but we'll just ignore that because it's not significant.
Yeah, it's not significant, so I don't know why you said it.
Well, we're 3 million miles closer. At sunrise, in December at noon, when the sun is 50 degrees in the sky, and I look at the sun, I can barely feel it on my face. I can't get a tan, right? But in June, when we're farther away from the sun, doesn't matter. And at sunrise, when the sun is literally an 89-degree tilt, the worst possible angle, as soon as it shows up on the horizon, I can feel the heat and I can get a tan. Why is that? Because in your world, it should be arctically freezing every morning all year long.
He wasn't very clear about what you're trying to say here, so I had to kind of break it down a bit in my head. All right, so you've explained to him the reason for the seasons, right? The tilt of the Earth and the fact that because parts tilted away, you get the same area, the same amount of light has to spread over a larger area, which means less energy per meter squared, right? And that's what causes the seasons. But his argument is that because the Earth is a sphere, right? Unless it's directly on the front of the sphere, the sides should also be a lot colder when it's night, when those bits don't have light on. Obviously, it is colder. It's colder at night, but he thinks that it should be as cold as the Arctic.
Yeah, I had at least 100 people comment on my page, just like, I know what he was saying there. I think I was just so fatigued by the stupidity at this point. At the end, I was just like, I'm done trying to make sense of what you're saying. But yeah, I think, you're right. What he was saying is, why isn't it as cold at nighttime in Florida as it is all the time in the North Pole or the South Pole or whatever it is? It's like, well, okay, in a couple of hours, it's going to be receiving that direct sunlight, right? The direct sunlight, and then the atmosphere retains it.
Now on to the seasons. There was a moment at the end of the exchange where I was more or less too fatigued after hearing an hour of stupidity to bother listening to him anymore, which is why I wasn't grasping his convoluted talking point, pretending that night and day should mimic the seasons. Let's ignore for a moment the fact that seasons have absolutely no logical explanation on a flat Earth and try and explain things in a way simple enough for even flat earthers to understand. The solar energy that reaches Earth from the sun isn't spread over the Earth evenly. If we consider a circle of light coming from the sun and hitting Earth at the equator, and compare that to a circle of light the same size hitting the Earth further north or south, you can see the same amount of light has to cover more of the surface for the areas of the Earth that are tilted away from the sun. In other words, the surface of the Earth at the areas tilted away from the sun receive less energy per square meter than areas pointing directly at the sun.
This is the reason we have seasons, because the tilt in Earth's rotational axis does not change as we orbit the sun, meaning everything that tilts toward the sun at one point in the year is tilting away from the sun 6 months later. Weiss made the ridiculous argument that at night when the sun goes down, or in the morning as it's rising, it should be as cold as the Arctic, because the sun is only offering a direct circle of light at midday, and at those other times, even at the equator, the sun's energy has to spread further, just like with the seasons. Of course, everyone knows that it is indeed colder at sunrise and sunset than at midday, but the main point Weiss can't grasp is that the entire area for a given latitude is still receiving more energy than the areas tilting away. It's not going to be as cold as the Arctic because the average energy received throughout the day is a lot more than the average energy received at the areas tilting away from the sun, which remain at that oblique angle for many months at a time, rather than just a few hours. We also have to understand that the surface of the Earth and the atmosphere retain and radiate back a large portion of the energy received during the day, which keeps these areas warmer overall. That's why it can still be relatively warm at night in tropical areas. This is very basic stuff. In short, the model we have of Earth explains the seasons perfectly, along with night and day and countless other phenomena, all simultaneously. Tough luck, Weiss. So, those were the 5 worst arguments made by David Weiss during our unfortunate exchange. Again, if you'd like to see the full discussion with FTFE, please visit his channel linked below and be sure to subscribe. Since none of the other prominent flat earthers have the courage to face me on a neutral platform, this should be the end of my flat earth content for quite some time. But I'll see you again for more debunking of other varieties very soon. Until next time.